CORD Insights and Challenges. My name is Larry Peterson. I'm the CTO at the Open Networking Foundation. What I'm hoping to do in the next few minutes is to talk about the history of CORD and give you a little bit of a retrospective about how things went. So just as a little bit of background, CORD was launched as an open source project of the ONF back in 2016. It's an acronym standing for Central Office Re-architected as a Data Center. CORD was a project operator partners and who were quite clearly very interested in bringing some of the economics of data centers to the edge of the network where their access networks live. And in fact, if you want to read about some of the just as an analysis of how CORD was launched as an open source project of the ONF back into 2016 deployment, you might want to read Who Dares Wins, a report put together by A.D. Little in collaboration with folks at AT&T, Deutsche Telekom, and Telefonica. But in any case, CORD started as an open source project. It is now, however, better to look at it as part of a larger ONF portfolio. You roughly can break it down into those components that are part of the SDN infrastructure. And for us, we focus primarily on software, so that's software implementation of the SDN infrastructure. We depend on and partner with people that are building white box switches and white box commodity hardware. CORD now, not just a project, it's actually a pretty significant part of umbrella for a lot of the portfolio of open source projects at the ONF. And so we now think of everything that lives above that, the SDN infrastructure, as part of CORD, and we talk about CORD-based solutions. But that's just kind of a very high-level roadmap. There are very specific open source projects that are part of this. So if we go down, and I'm not going to spend a lot of time here, but part of the SDN infrastructure, sort of at the heart of it, is ONOS, which you may be familiar with. ONOS, the Open Network Operating System, is the SDN control, the core of the SDN control plane. We now also work with programmable switches with P4 and Stratum as the switch operating system running on the switches. And on top of that infrastructure, then we build different control applications to manage the network trellis is a predominant one. And then on top of that SDN infrastructure, then live the CORD solutions, which you can think of as having the CORD platform as the foundation for that, and then solutions in both the mobile 5G direction and in the broadband direction. So moving up the stack, in the 5G solution direction, you'll find COMAC as sort of the main project, but it has some projects that are now actually becoming quite important. OMEC is the Open Mobile Evolved Core, and SD-RAN is the based implementation of RAN. We are now working on Aether, that is sort of a culmination of pulling that all together, and I will talk a little bit more in depth about Aether in a few minutes. On the broadband side, the access solution now is called SIBA, and if you break SIBA open, you will find VOLTA and software-defined BNG. VOLTA stands for a virtual OLT hardware abstraction. But you see, the idea here is that we have a well orchestrated and coordinated set of open source projects. The top half of the stack collectively are part of the CORD solutions. But up and down the stack, these solutions are being commercialized and put into production. So if we go down and look at the SDN infrastructure specifically, ONOS and Trellis are today running in production in Comcast's network. ODTN, which is a marrying basically of a packet-based optical network, is in field trial with Telefonica. Moving up the stack, OMEC, the evolved core, source evolved core, is in production with T-Mobile Poland. SIBA collectively is in trial on its way to production at both Deutsche Telekom and Turk Telekom. And SD-RAN is now a really highly visible and major project that ONF is working on in collaboration with partners at AT&T, China Mobile, China Unicom, Deutsche Telekom, and others. This is an open source implementation, paralleling and complementing the work that's going on in the ORAN Alliance. And finally, Aether at the top is now you can think of it as kind of a capstone project that's pulling a lot of the subsystems underneath it together, and we are piloting with several of our partners a deployment of Aether. And like I said, I will come back and talk about Aether in a little bit, because in many ways it is the 2020's version of Cord that we're actually putting to deployment. So that's the portfolio, and again, Cord now, it's better to think of it as a major component of the entire ONF portfolio. But what I wanted to do was trace its history and how did we get here and what lessons did we learn along the way. So to do basically a little bit of a retrospective. So the history is that Cord started out as an architecture and a platform. It was a set of architectural principles that we were designing a system, and we built out a software platform that embodied those principles. So if you go back to the original literature back from 2016, those architectural principles, basically the design principles that shaped Cord, they involved taking advantage of the economies of commodity hardware. Again, this is directly learning from the use of commodity hardware in data centers, cloud data centers, and the idea was to apply that to the edge, to the central office, and to the access networks. It was also an opportunity, or it was an important design principle that Cord be able to support innovative edge services. Again, Cord was designed for the central office or whatever you call the edge of the network. And we were interested not just in running virtual network functions, which were all the rage when Cord was being designed, but also those functions that were really important at the edge, IoT functions, working on bringing AI to manage different infrastructures at the edge. These were all part of the bigger picture of the innovative services we wanted to run at the edge, including virtualized network functions that you might have already had living in the central office. We designed Cord specifically to be extensible and controllable. And the important point to make here is that Cord was not a point solution. It wasn't designed to solve exactly one problem. It was a general purpose cloud that you could load different solutions into. And as a consequence, it needed to be extensible, but then once you extended it, it was still part of your operatable network, and you needed to be able to control it. So simultaneously being able to extend Cord and control it was a key design principle going back 4 years. The fourth principle was that Cord support multi-domain security. We did not believe there would be a single trust domain, that in fact there would be both operators and third-party services and tenants and so on. So multi-domain security was a cornerstone of Cord as we originally conceived it. And finally, we were trying to be complete in the design of Cord and pay attention to operational robustness. So we were trying to bring the best practices of DevOps from the cloud and apply it to the access network at the edge. So I highlight these because they shape the evolution of Cord through the years, and in fact, when we get to the end of the journey today, or not the end of the journey, but where we are in the journey today in 2020, you're going to see that these 5 principles still apply. But in any case, to return to the journey part of the story here, Cord again was a platform, but a platform is only as good as the use cases that you load onto it. And so originally we built Cord and we built some point solutions on top of that Cord platform. They were known as R-Cord, E-Cord, and M-Cord. R-Cord was targeted at residential use case, so it was basically targeted at passive optical network. E-Cord was targeted at enterprises, so we wanted to connect enterprises to the metro area network and to each other. And M-Cord was targeted at the mobile use case, and in particular 4G at the time, and evolved into 5G as well. So these were use cases, and the whole idea was Cord was a general purpose platform. Then we would load different profiles into that platform. Now, at the time when we were building R-Cord, E-Cord, and M-Cord, they were essentially proof of concept. They were sufficiently complete to make the case that Cord was a viable platform, but they weren't yet ready to deploy solutions in their own right. And so the next phase of the Cord journey was collaborating with operators who wanted to take the promising proof of concepts all the way into first actual trials and then on into production. And in this case, it turned out that R-Cord and M-Cord were the ones that got the most traction. E-Cord was interesting, a lot of people were interested in it, but it didn't quite get the take it to production traction of the other two. But in any case, SEBA, which stands for SDN Enabled Broadband Access, was a deep dive on what started out as Cord, fleshing it out to make it viable and production ready. And on the other side, MCORD evolved into COMAC, which stands for Converged Multi-Access and Core. It's got multi-access in it because the intent is to eventually get PON folded into it as well, but it very clearly is sort of the next evolution of what started out as MCORD in the mobile case. So in summary, where we are here is we took the proof of concepts and we brought in operators and their requirements, their hard requirements. These are requirements from the operational people so that we could get to the point that we could deploy SIBA, for example. Now, in some sense, you can think of this as little more than a rebranding. SIBA is a rebranding of ARCORD, but it took on a life of its own because we brought in, again, all of the operator requirements having to do with FCAPS and reliability and robustness and so on. In the process of doing that, we drilled down, we built out, and we ended up with 2 viable subsystems that are part of SIBA. So whereas SIBA is basically an in-depth, more realistic version of ARCORD, both and SDBNG are subsystems of SIBA. And they turned out to be important enough subsystems that both, for example, virtual OLT hardware abstraction is a self-contained project of the ONF today with people using it in its own right. Software-defined BNG is a little earlier in the process, but we also have partners that are building it out. Likewise, on the COMAC, as the follow-on to MCORD side, it has evolved into 2 other subsystems that have taken on pretty significant importance in their own right. One of them being SD-RAN, software-defined RAN, and like I mentioned a few minutes ago, this is an implementation, an open-source, community-driven implementation of a RAN that takes advantage of SDN principles, used to demonstrate and to make real all of the work that's going on in the ORAN Alliance. So it's very much teamed up the same set of partners, AT&T and OMEC, like I mentioned before, is our open evolved packet core, and again, it runs as a self-contained system. So the takeaway here is in the process of building out these solutions, SIBA and COMAC, we ended up building out very significant subsystems that effectively are standalone and have a life of their own. So just as an example, there are partners and other operators that pick up VOLTA and plug it into their edge deployments, not necessarily taking on all of SIBA as well, but VOLTA, like I said, is a self-contained standalone open software project, open source software project. The same thing with SD-RAN. So kind of the lesson here is as we build systems, we discover there are other systems that also need to be built, and we work on those as well. And that's kind of in keeping with the curated open source model that ONF adheres to, and that all of these parts are designed to fit together. We're not just taking things out of left field. There's a rhyme and a reason as to why all of these projects come into existence and how they plug back together. But this brings us today, which is Aether. And the way to think of Aether, I believe, is it's sort of a capstone of all the lessons we've learned, and it is in fact something that we're operating. Now, historically, ONF has been an organization that produces and makes available open source software. And we make it available to our partners that operate networks. We're sort of eating our own dog food here a little bit, and we are at ONF actually operating Aether. I mean, obviously, we're not a large telco, so it's a much more modest attempt, but it is an operational deployment of all of these components that we've built here. Now, it follows across this history. Its closest tie is way back to MCORD, and SD-RAN and OMAC are 2 critical subsystems of Aether. But it is, and again, Aether is certainly squarely in the making available at the enterprise, at the edge, 5G and 4G access technology. But the other point I wanted to make is that we didn't leave. It's not independent of SIBA. We learned a lot in SIBA. We wrote a lot of software in support of FCAPS. Monitoring and logging and so on, just as an example, that have been brought along from SIBA and are now part of Aether, even though maybe the rest of SIBA is not in terms of support for PON. Many pieces were brought along. And in fact, eCord also has an impact on Aether. eCord, we're not taking any software from eCord. This is too long ago, and there wasn't an awful lot to bring along. But just in terms of the lessons learned about the architecture of supporting multiple sites, not just a single edge site, not just a single central office, and to run that as a managed service. Those are principles of eCord, and we learned a lot several years ago, and those ideas have been brought forth and are part of Aether as well. So if we kind of stand back from this, the point I wanted to make is just that it's been a 4+ year journey. We started out with an architecture and a platform, which we populated with specific use cases. Some of those use cases got traction, and we fleshed out based upon operator requirements to make them real. In the process of making them real, we discovered additional open source projects that had importance and value in their own right, and those are being built out as well, and they're standalone projects that you can pick up on their own. And finally, there is value in pulling all of these pieces together and actually deploying and learning from an operational system, and that's what we're doing today at Aether. And it's got a particular flavor to it that includes both mobile and enterprises. And so I want to come back to that because I think this is an important part of what we're going to see going forward. So Aether, in a nutshell, is a managed 4G, 5G edge cloud for enterprises. It's managed from the central cloud. It's intended to run in enterprises. It's an edge cloud that runs in enterprises, but that edge cloud is just not a vanilla, is much more than a vanilla edge cloud. It's an edge cloud that is capable of 4G, 5G connectivity to the edge devices. Now, I just wanted to remind you that if we go way back to Cord and pull forward the architectural principles, they all apply to Aether. Aether is in some respects a reimagining, a deployment now of Cord in a particular use case. So in the way of an overview, this is a busy slide, but Aether, like I said, runs at the enterprise, so everything to the left of the dotted line is a single enterprise, and it includes IoT, sensor, surveillance, multimedia, and you've got both employees and visitors coming and going. And they're all connected by small cells within the enterprise. Those small cells might be running on licensed bandwidth, but it might also be running on unlicensed bandwidth like CBRS in the United States. There is then an edge cluster. In the original Cord, we would have called it a Cord pod, but now we call it an Aether Edge compute edge, an ACE. It's basically a cluster of commodity servers and switches. It runs Kubernetes, and it hosts a set of containers. We run the Open RAN controller to manage the small cells, and we also run the user plane of the mobile core at the edge. And the point there is that we can do local breakout. Traffic that originates in the enterprise never has to leave the enterprise. It can be operated on and processed by an edge application. Some, of course, go onto the cloud, and that's where we then get to the right-hand side. Because in the central cloud is where we manage these edge ACE pods. So this is a central cloud, and while it runs in, we've demonstrated it in different clouds, the operational version of Aether runs in the Google Cloud. And it includes the control plane of the mobile core. It includes any central apps that are being paired with the edge applications. But the other thing it includes is the management platform. So one of the biggest distinctions between Cord and Aether is Cord was a bit more standalone, and the management plane ran on the pod, on the Cord pod. What we've done is we've just moved that centrally, so that we now centrally manage a set of Aether pods at the edge. That's called AMP, the Aether Management Platform, and the important thing is that it has and includes an enterprise control portal. So enterprises, through that portal, can control and manage the deployment of Aether in their edge enterprise. They can decide what edge applications to run. They can allocate network slices to different applications and control the capacity of their cellular network as it's applied to different applications. Now I'm showing a single edge pod or edge site here. Of course, this is a centrally managed service that has multiple edge sites. And so there are many ACE pods distributed, each running their own edge applications. If you are a single enterprise with multiple sites, then those multiple edges are all orchestrated as one network with seamless end-user roaming. Of course, if there also are multiple enterprises, and Cord enforces the appropriate isolation between them, as you would expect, because it does support multi-tenancy and multiple security domains. So, as I said, this is where Aether is today. It has been operational since December of last year. And it includes both the central component, which is the AMP, the management platform, and the control plane of the mobile core that lives in one of the Google data centers. And then there are a set of ACE pods currently distributed across the world. So again, it's been operational, and we are basically taking many of the subsystems that have grown out of under that core umbrella, and we've now brought them back together in Aether. So thank you for your time. If you would like any more information, you can find control plane of the mobile core open networking website that lives in one of the good information about Aether. And if you're interested in joining and running an Aether pod, we'd be happy to hear from you.